to begin with, I want to make sure that people have the updated the table or the exercises or whatever, because I made changes to the exercises in the weekend. So you need to, if you downloaded a table, you need to download a new table. And if you went to prepare the environment and then to use the table, then you can scroll down to step 4, and there is the table. And the other option is to go to GitHub and clone it. And we do that by simply copying this here and write git clone and the URL. And I am going to go to the storage directory. There's one on SPC2N. It's named slightly different at different places. So if you are at the Rackham, this is the name of it. If you're on Kebnekaise, you find it here. If you're on Cosmos, this should be ignored. There isn't one. You make one in a directory in your home directory. And the other two for Tetralyt and Darden are these ones. So I will just go to the directory here. Yes, okay. So as you can see, I have a directory there, and if you hadn't created one the other days, then you should do so now. And otherwise, you can just copy it. In this case here at SPC2N, I have cloned it. And if you wanted to clone it and have it, you say git clone, and then this here. So you would do like this. Now I already cloned it, so I can't do that. But I'm going to go into the directory created, and then I'm going to do a git pull to get everything updated. And meanwhile, I will check what I have at the UPPMAX, and there I had done the same. But you know what? I'm just going to do fetch the table, just to do 2 different things. So I will copy this. And then I will use this command here to untarget. So in this case, I get a directory called exercises, whereas if I clone it, I get the directory SPC Python. Within the SPC Python is the exercises directory. So in either case, you can go to exercises, and there in the directory examples are the exercises for this session. If you were looking for the ones for the pandas and for Seaborn, they are here in the top directory under exercises. So I will go into examples. And as you can see, in both cases, there are some directories here. There is one for UPPMAX, one for PDC, one for NSC, one for LUNARC, and one for SPC2N. They contain batch scripts, and we will talk about those in a very short time. In the directory programs are the Python programs. So you'll find those there. Okay, well, let's go back to the presentation itself. So in this lecture, I'm going to talk about what's a batch job, what are important commands regarding batch jobs, and how to make a batch job. And this is going to somewhat build on the interactive job session Friday, because there we were also using the batch scheduler, the Slurm batch scheduler, to create an interactive job. And here, instead, we are going to write a batch script that is used to submit your jobs to the compute nodes. So here it will not be interactive. Here, everything you want to do to the job needs to go to the batch script because you cannot change it while it is running. So first, I will talk a little bit about the Slurm scheduler commands and then show the structure of a batch script, and then there will be examples for you to try. And this is, again, the project IDs. You're going to use them in the batch scripts in order to tell the batch scheduler that you are running in this allocation. These are the storage spaces. We talked about those. There's also reservations, which we're not really going to use because we have short programs, but on UPPMAX it's magnetic, so it will use automatically. If you wanted to use the reservations at HPC2N and LUNARC, then you add this part here to your batch script. And you can see it's different for each day. At HPC2N, it looks like this for today. On LUNARC, it looks like this for today. So you would simply add this here into this here, where it's reservation name, if you're on LUNARC. This here, if you're on HPC2N. On UPPMAX, it's used automatically. We don't have reservations at Tetralit or at Darden. So this will look at running programs and scripts on UPPMAX, HPC2N, LUNARC, NSC, and PDC. However, what is covered here will, with small differences, be valid for all centers that are running the Slurm batch scheduler, which is, as far as I know, all the clusters in Sweden and many in elsewhere as well. So any longer resource-intensive or parallel jobs, or for that matter, GPU jobs, must run through a batch script or in an interactive session on allocated compute nodes. As I said, batch jobs are not interactive. You can't make changes while the job is running. So you need to be sure that you have everything there before you start running. In order to run it, you create and submit a Slurm submit file. It's, if you Google it, it's called a batch submit file, a batch script, a job script. It may even have other names, but it's all the same thing. It's just different names people are using for it. You can find guides and documentation at each of the centers. So the workflow, if you're going to make a batch script, is you write it. Inside the batch script, you load any modules you need, Python on Python packages, prerequisites, whatever you need there. You may activate an isolated or virtual environment if you have some own installed packages. And you also ask for resources depending on if it's a parallel job, serial jobs, GPUs, and so on. And you also give commands to the Python scripts. All these things are done in the batch script. Then you submit the batch script with the command sbatch and the name of the batch script. You can call the batch script anything you want to. It's common to have extensions like .sh or .batch, but it's not necessary. Choose any name that makes sense to you. These extensions are merely used in order to make it easy for you to see in your directory which files are the batch scripts. Some useful commands. As I mentioned before, sbatch to submit the job. To get a list of your job, sq -u username, or more directly, sq --me. To check on a specific job, s-control show job and the job ID. The job ID you get either from this list here or from when you submit the job. I will show you in a very short time. To delete a specific job, you can use s-cancel and the job ID, or you can say s-cancel -u, your username, to delete all your jobs. SACCT and this line of flags here will give you useful info to a job. like how much memory was used and things like this. It is a very wide output, so you pipe it with this vertical bar here to the command less and give it the flag -S, which makes it sideways scrollable with the arrow keys. In order to get a URL with a page with info about the job, a graphical representation that kept Kaiser, you use this command. There are similar commands at some of the other centers. I don't know them right now. We need to get a list of them, or maybe get them set up and installed. But this command here will always work. So an example Python batch script. And now I would like you to type along. And it would be good if you had fetched this tarball or cloned it. So please make sure you have done that. And here we will run a short serial script. And the batch script I'm going to use here is with this name here, run_mmmult.sh. It's a matrix multiplication. And that can be found in the directory here. If I go to programs, the one that I'm running is here. And if I go into the directory for the center, there is the one to run it. So you can find them there. And yeah, I'm now going to assume that you have the exercises. So I'm going to try and submit this batch script. And before I do that, I'm going to show you how it looks. Just go into the one for SPC2N here. And you can see it's here. And I'm going to open it with Nano. Nano is an editor. Other editors on Linux systems are, for instance, VI or Vim. There's also Emacs, but I think if you don't have one that you prefer, use Nano. It's an easy one to use. If you start typing something and hit the tab key, then it will autocomplete if there's no other options. Otherwise, it will autocomplete as much as is possible. But in any case, it usually will help you type less. So, okay, so let's look at this serial script here. The first line here is sort of an incantation I get. It's called shebang here. It is a command that is just telling the batch scheduler that you want to run it on the bash terminal. It doesn't matter, it just matters in the way that this is the one that is compatible with the batch system. So just make sure you have this line. Then change to your own project ID later if you're running this after the course. The project IDs will be good for a couple of weeks, I believe. And then you need to get your own project if you want to continue using it. But HPC2N, this is the project ID. There should be the one for the center added there already if you go into the directory for the center you're at. So this command tells it which project to run in. This A must be capital. These commands here, #sbatch, are commands to the batch system. They must be typed in capital letters and they must have a hashtag in front. If you wanted to comment out one of these, you would add another hashtag. 2 hashtags here in front, then it's commented out. So here I ask for time. Time is hours, minutes, and seconds, at most 1 week. Here I'm asking for 10 minutes. And here, how many cores or other tasks, but as default, there is 1 core per task. And here there is one thing that is not in the example here, which is I set the path. And here is something you need to make a change to, because this path here must go to the directory where the programs are in. And in my case, I'm going to go down here and change it. The one line that I need to change, because I cloned the directory, is my directory here is called my username, and I remove the rest here. So this will be correct here. I will also open it on UPPMAX, because on UPPMAX, I instead downloaded the tab with wget. And that means that, of course, I still need to put my username here. Sorry, I used VI, I will use nano. I apologize, I'm used to use VI. There is here my path. So go down here and then change it to your username where it says my dear name. If you downloaded the tarball with wget, now you remove this directory here, HPC Python. That is only there if you got it with git clone. If you are on Cosmos, then there may be a different path here in the beginning, because you put it in your home directory, in some directory. So this part here, you would have to change to whatever you call it if you are on Cosmos. But otherwise, this is correct for a downloaded tarball, and this is correct for a cloned Git repo. Okay, the path is now set. So now the system knows where to look for the programs. I'm making an environment variable containing the path to the programs. Yes, someone raised hand.
Sorry, I have a very stupid question. Where this path is where the bash script is, or where the Python program is?
This is where the Python programs are. So when I'm running, because it's a directory for each of the centers with the batch scripts, then I need to set the directory path to where I put the Python programs. Or I guess I could have copied the Python programs to each of these directories. But in any case, the batch script needs to know where your programs are if they are not in the same directory as the batch scripts.
Okay, for this exercise, which Python program, what is the name of the Python program we are going to run?
This one here.
Okay. Oh, I see. Thank you.
So if you're simply copying it here, then you can just put it in the same directory. But if you're using the downloaded tarball or a Git repo, then you need this path. After setting the path, making sure you can get to the programs, you load any modules you need. Here I'm loading Python 3.11.3 and a SciPy bundle. SciPy bundle is something that some centers have, which contains things like NumPy, Pandas, SciPy, and things like this. On UPPMAX, everything is included in this Python package, so Python module, so you don't need to load anything else. Then comes time to run your script. If the script has variables, input parameters, you would add those here as well, just the way you would do if you ran the Python script directly. But now this is correct, and I'm going to save it. And to save a file in Nano, you hold down Control and press X. Then it asks you, do you want to save it? I say yes. and then it asks, do you want to save in this file that you used before? I'm going to do that. I'm doing the same at UPPMAX. Okay, now we have a file that we can run, a batch script, and I'm going to submit it with sbatch and run and the name of the batch script. So I'm submitting it, and I'm also submitting it on UPPMAX like this. And as you can see, in both cases, you got a job ID. And this job ID was the one I talked about up here. So you would use that and also here. So for instance, I could say scontrol show job, and then I type this job ID 345360021. I then get a long output here with info, and if it hadn't yet started, it would say so here, and if it was running, it would also say here, but now in this case it's completed. It tells you things like how long did it run, and how long was it allowed to run. This was the 10 minutes. When did I submit it? And when did the job start? Because maybe it's set in the queue folder. How long, when did it end? And so on. And it also tells me which partition it ran in. So it tells me it ran on the Zen 4 CPUs at HPC12. It tells me the name of the node it ran on. And it tells me how many CPUs it used, or how many cores, sorry, how much memory it used, and things like this. It also tells me what the work directory was and which batch script I submitted. All these things can be useful if you're later debugging or if you're checking where the output came. Now, you can name the output if you want to, but if you don't, all output will go into this file, slurm minus the job ID.out. And you could check it with nano, or you could check it with, for instance, less, which I'm going to do here. And then you see the output is the output you would have gotten from running the Python script otherwise. The same thing happened, of course, at UPPMAX. I'm now going to submit several times this job so that I have time to start an SQ for it and run SQ and see what is going on here. And you can see it ran very fast. So I'm going to do the same at HPC2N, and then I'm going to try and start the SQ faster so that I have time to see some different stuff that I can talk about here. See. So it's all running, and now it's all completing. So now we have the three of the states. When you have just submitted it, it may be pending. So this list here, SQ minus me, that is the same as SQ minus you, your username. It will tell you the list of the jobs you currently have that are in the queue or are running or are completing just now. So it also tells you the job ID, which you can use here to get info or to cancel the job or other things. And it tells you the partition, it tells you the name of the job script, unless you name your job, it tells you the user and the status. The status could be pending, it's waiting in queue to be allowed to run, waiting for resources to be available. It could be running, and in that case, it also has a time it has run. It has how many nodes, or rather cores. This is probably our old type of output, but it means how many cores. And then which nodes it's running on. And it could be different ones. After it has ran, it will be completing. And then you can see how long it took. So I would suggest that you try this out. Go and open this, go into the directory on the system you are at, and then change the file that I showed you. So you can quickly find it. Open with nano, and this run_mmmult.sh. Open that. Make the change to my path so that it is correct. The place you will have to change it, possibly these two. And then save it with Control X and say yes and save it, and then submit it with SBatch and this name here. And then see it's working. And then you can take a look at the output. So let's take 2 minutes, and so everyone has a chance to try and do this. Yes.
Could you remind me what did this /dev/null did, and what is that whatever after that is? Yeah, this line. Yeah.
Yes. On some of the systems, it is recommended to remove any modules that were already loaded. This is mainly the case for LUNARC and SPC2N, and I believe maybe also Tetralit. You don't need to do that on UPPMAX, and you should not do it on Dardel. But if you are at the SPC2N or LUNARC or Tetralit, then do that. What it does is it's a module purge has an output. And you don't, if you want to avoid that output in your output file, because it might be confusing to have the output there, then I'm just throwing it to dev null. So this just means throw the output there instead of putting it here, and do it for both the output and the errors.
Okay.
So that is it's sort of it's just a line to make it look neater, I guess.
You said I should not do it on Dardel. What if I do it? Like, what will happen? Should I try to do it?
If you do it on Dardel, then you will remove a lot of modules that needs to be there and that takes care of the environment.
Okay, I see.
So if you do that, the easiest thing to do is to log out and log in again.
I see. Thanks.
There is another question. Maria.
Yes, sorry. I was checking the useful commands, and one of them is useful info about the job as act. What information does it give?
Just a moment.
I tried to do it in mine, and then it was taking a bit.
It will give you it should give you a long output. So let's copy it. And then I will change the job ID here to one of the ones. Let's take this one here. And then you get a very long output that you can scroll through. And for instance, here you can see, well, you can see what I think I need actually. Okay. You can see how much data it used. This is very small program, so because of that, it doesn't really give you much output. But you can see the partition and things like this. You can see how much memory it used, and you can see which node it ran on and things like this.
So it is worth checking it if you want to optimize your workflow later on, and then see
yes,
resources and so on.
And it's worth checking if your job crashed and you suspect that it used too much memory.
Okay.
Because then you can check if it ran out of memory.
And then a very silly question. How do you come out of this? Because it was end in brackets. How do you come out of this?
Control Z.
Thanks.
And I could see if I can use job usage on the same one. But this will only work at HPC2N. But this one gives you a graphical output. Yeah. Copying it. I have issues with the zoom bar. So since this ran too short, it's worthless. But if it runs at least like 30 seconds to a minute or something like this, then you will get graphical output here that shows you how the job was doing, how much memory it used, and things like this. But it needs to run for at least 30 seconds, and this job didn't run more than 4 seconds or something. But that is otherwise useful if you are at HPC2N. Otherwise, should go with this one. Okay, I am going to continue to the next example. And let's see, what I have okay. What I want to say here is, imagine that you have installed some packages yourself. And if you do that, then of course you need to load them. You need to actually activate this virtual environment within your job script, because otherwise you cannot access these programs. So it's exactly the same thing as if you were working with Python on the command line. You need to activate the virtual environment. And you do that the same way, it's just that you do it inside of the batch script. So you simply make a line where you source the path to the batch script, to the virtual environment that you created, /bin/activate. Then this virtual environment is active. That means you can access the packages you have installed there while you run your Python scripts. And there will be such examples tomorrow. So, and this is just a very simple example on how we would run a Python script that has a Java array. So you could, this is a way to run several instances of a script directly. For instance, in this case, this Python script just takes the number of tasks, but maybe you had one that you are running for 100 different arguments or whatever. Then you could do that, and then you would set up an array. In this case, I'm running it for 10 an array for 10 tasks, and yeah, so you can change that to how many you want. Other than that, there's no differences really. And again, you set the path, and again you load the modules and run your Python script, with the difference that in this case you add Slurm and the Slurm array task ID. Talking about SRun, you may have remembered we used it yesterday for running stuff on the interactive session at HPC2N, but it is also used to run more instances of something. If you, for instance, have a parallel code, an NPI code, then you will always start it with SRun and then the Python script. This is a simple example of a batch script, and it doesn't look so simple because all the centers are compressed into one. But there are examples in this directory here where you can look at. For instance, there's one here that's called integration to the NPI SH. And yeah, I don't It's actually using MPI1. It should use S1. So. But the main difference if you're running an MPI job, a parallel job, is this one line here. That is the important one. You ask for more tasks to run, and then you add S1. Those are the two main differences. You will also notice that if you need MPI for Pi, it's not installed at all centers. And if it's not, then you will need to install it in a virtual environment. If it is installed, then you just use it, and it is installed at many centers, as you can see. I will also just quickly mention how you ask for a GPU, though I will mainly talk about that tomorrow. And if you want to, you can try and run it. We will do that more tomorrow. So here, it's just how you ask for a GPU differs between the centers more than many things. You can see here there are different ways to ask for it. And another thing is also you need to make sure that the Python modules you are using here are actually the GPU version. And you, of course, need to make sure that your code works on the GPUs. Good. I think that we have time for the exercises as planned. Good. This serial example that you tried to run before, the one that was called remote, that one you can use the batch script for that and instead try to run this other script here. And I would like you to try and do this exercise here. And in this case, you simply modify this script, serial script, yeah, this one. Try to modify it. So, sorry, this script. Modify this script so instead of running this one, it runs this one here, some two args. And it's not just adding in that script, there is another thing, namely you need to give two arguments to it. So I will let you try and do that. And there are solutions for it, including in the directory, but I want you to try to do it yourself first. And after that, there is another exercise, challenge, or what you want to call it. How would you run a pandas matplotlib example as a batch job? There is a small script here that does a plot, and of course, since you cannot do interactive stuff, if you try to plot something in a batch script, then it will not show. So you need to instead save it. So try to make changes both to the Python script and to write a batch script that will do this. And you can use the same batch scripts as before and just modify it. But remember, you probably need to add some different modules. In fact, these are listed here. And you can find this also, the answer to it, in this directory here. It's here. But please try to do it yourself first. You will take, if your word is Birgitte, you will take the script here. I will just create my temp script, .sh, and I will copy it here. Now I used, sorry, I need to remember to use nano. And here I just paste this content here. So this is the script I want to edit. And I want to edit it so that I can run this exercise here. So the first thing I do is that I change it to this name here. That would be the first thing I would do because I want to run this script instead. So I will try exit here. And yes. And then I will also put this script here in this directory. So, right. And then I will copy that here. But as you mentioned, this script here, let's try and see what happens if I just run it. And it will give an error. And the reason for that is that it wants 2 arguments. So I will give it something, and then it works. And that means, of course, we also need to do it in the script. So let's go into the script and make a change here. And I will just add some numbers. And if I do that, and then submit it, then it should create a output file, which is this one here. We'll see if it has finished running. It has. So then I will look inside this file here. And it has correctly added the 2 numbers. So this is the output you would expect to get.